In this lecture, we will continue our discussion on array operations.
We'll next look at how we can search for elements in an array. Let's suppose we have an array that contains 100 integers. And let's say we have some specific value and we want to see if this value exists in the array. And let's take it one step further. If this value actually does exist, so if we look in the array and we find that this element does exist in here, we'll get the index of where that value is located. It's not enough just to say, yes, it's there. We can get the index that tells us exactly where it is in the array. What would be the simplest way to see if an array is in there? Well, the simplest approach would be just to start at the very beginning and just check every single element. So we just start from the beginning, check the first one, then check the second one, check the third one, and just keep going. And if we do find the value, then we just immediately stop because we found it. We don't need to search any further. If we don't find the value, so if we get all the way to the end of the array and see that it's not there, then what we can do is just return some index that we know is not possible. And since we know that an index in an array must always be a non-negative integer, we can return something like -1 to say, all right, it's just not in the array. This approach is a very common approach for searching for elements, and this is what we call a sequential search. And it's called sequential because we're searching for array elements in order. Here's our code for the sequential search algorithm, and I believe we actually went over this in CS 121. So we pass the array, which we call A, the size of the array, or the current number of elements in there, and then the key, which is the element that we want to find. So what we have in here is a simple for loop where we have I as our loop control variable. We start at 0, and we keep going as long as I is less than the size of the array. And all we're doing is just this main comparison right here, where if AI is equal to the value that we're looking for, so as soon as we find the value that we're looking for, we just stop and we immediately return I, which is the index of where that value is located. Now, if we get out of the for loop, then we know that the value is not in the array, so this is where we would return the -1. So what's the running time for sequential search? Well, let's suppose our array is of size n. And let's look at the 3 different scenarios that we talked about before. The best case scenario would be that the first element is the key. So this is just going to take constant time because we just do one comparison, it's there, and we're done. What's the worst case scenario? Well, in this case, either the last element is the key, or the key just isn't in the array at all. In either case, we would have to search the entire array. We would have to compare each element in the array. And this is going to take O of n time because we have to search all n elements. Now, what about the average case? Well, on average, we would have to check probably about half of the elements in most cases. Well, I shouldn't say most cases, on the average case. So that means we would need to check n over 2 elements, and this would result in n over 2 time. But we've already mentioned that we ignore constant factors, so we take out the 1/2 part, and this also becomes O of n time. Now, as we mentioned before, whenever we're analyzing algorithms, we need to consider the worst case scenario. So that means the running time of sequential search is O of n. The question we should ask ourselves is, can we do better than sequential search? You may think that the answer to that is no, that we have to check all the elements to see if it's there, right? Well, it's not necessarily true. Now, if the array isn't sorted in some order, then yeah, we can't do any better. If they're all jumbled up, we're going to have to check all the array elements to see if our key is there. Now, if the array is sorted, we can do better. And we'll talk later on how we do this, but if the array is sorted, we don't have to check all of the elements. Now, another question you might ask is, well, in the vector class, we have the index of method, right? Doesn't that do the same thing? We just input some character or some element, I should say, that we're trying to find, and it gives us the index of that element. Well, you would think this is a constant time operation because we're just calling a method and it gives us a result. But this method actually uses the sequential search approach. It does search all the elements of the vector and then it returns the index that it finds. So this is not a constant time operation. It's actually an O of n time operation.